Okay, let's start with the base application, procmt Mini. This will be later embedded in different software. And create a survey wherever you like and create a new folder and say oil and gas, for example, and press OK. At this moment a new folder is created, and as we can see we have a directory structure which is empty. Here you would put some calibration data for override. If you have old coils, you don't need it. If you have the 8U8E and the E-series sensor, we have some control source folders, we have database folders. All these folders are empty. The EDI folder will be populated with the results. With the job list editor you can store some jobs here, some pre-configured jobs. These jobs will be executed by shell scripts. Stored processings are here, and in the time series directory you can now create your first station and say, for example, line 1, site 34, and in this folder you now put your data from the ADU. So if you have measured some data, here we have some old data, we can now copy this from the ADU and put this inside the folder. Either you select by browsing the folder which is already populated here, or alternatively it's no problem to use drag and drop, same result. If we have done this, we can then select a station, and in our station we use the center station, and then we say next, and we can see that we have some pre-selected settings here, and that means medium means that we use a FFT which is not too long and not too short. We can override these settings here by making longer or shorter FFT. This depends on the noise level, and we can have more or less smoothing. So at this moment we take the default. Here we have additional settings which apply after we have done the FFTs and we have calculated the tensors. Then we can check the quadrant, we can check a coherency threshold, which is by default set to 0.8, and we can then do this again and again in order to optimize our result. So when I press run first, the data will be calculated and we have a result according to our recordings. Now, as we have seen, the result was not showing very deep frequencies because we have only measured two frequencies. We have the 2 kilohertz and the 128 hertz, but this was almost 1 day. So we want to have some lower frequencies, and this we can achieve by running a filter which down filters the data several times, so-called cascade filtering. So we can put the site here and drag and drop it on the application. By default a 4 times decimation filter is selected, and now we can filter and filter again in order to obtain lower frequencies. If you press auto extend, the filter tries to down filter automatically again and again until the file size is getting small, but it will stop before it gets too small. So when I press run, we can see that we now get additional frequencies here, and the filter decided down filter to 8 seconds period. So if I select again and start from the beginning and say next. Then we can press again run first. And now, as you can see, we will have much more frequencies. And still the old result is available. So you can see that with downfiltering you obtain much more frequencies. In order to remove all previous calculated settings from the EDI plotter, we can clear the EDI, we can reset the tensor. That means all statistical calculations are not stored anymore, and instead of running first, the spectra are still in the main memory, we can say recalculate tensor, and then only the last result is shown. As you can see, there are some instabilities at the highest frequency, so we can now try and evaluate the data, and this we do by spectral editor. This needs a large amount of memory, so smaller computers may crash. And now we see that all data, all tensors are displayed. So this is the set. Let's go, for example, to the 15 Hertz data, and we see red is deselected and blue would be selected, which we can't see here because there are maybe too many stacks, but we can see that we have a distribution of the XY phase and XY resistivity. And if we zoom in, we can see that some points are outside a standard deviation and the other ones are inside. The same we can do for the tensor. And remind that we have set the quadrant check, and this says that data which are for the XY component, for example, in the negative range are automatically selected. And here you can see by pressing the right mouse button and move which data has been selected. So I can make changes for processing, for example, and maybe take a different frequency, move it, and we can say, for example, here some data at the near to zero phase we do not want to have. So in this moment I can press freehand and say not to be processed, and I now can, if I want, with the left mouse button, which has a small phase, will not be processed. So I press accept, and then I say recalculate tensor, and now I should be able to see a small difference between the first and the second one, but obviously in this case, and that is quite natural, the first shot may not be successful. So this takes some time in order to get an enhancement. Alternatively, you can now try and say reset tensor, so all statistical data is reset now, and you can now say we use some median estimator, and we say from the median estimated row we only want to take plus minus 1.3, so that means we limit the allowed resistivities, and then we say recalculate tensor and get the next result. As you can see, there are some slight changes. Each result is stored in the EDI directory. So as you can see, we append 1, 2, 3, 4, 5 and so on in order to get all values saved, so that at the end, when you have done several processing, each result is stored and you can then compare which result is the best for you.